To my YouTube channel all about VLSI. In this particular video, let's discuss one interview question with the solution. So the format of this video is you can pause the video and you can read the question and you can answer and you can resume for your cross verify your answer, right? So the first question is what are the synthesis implications of using a variable as a vector index in Verilog? How does a synthesizer implement it? So let's take a variable over here. Let's say if I'm going to have range 31 down to 0 data and reach 3 down to 0 nibble. Now, let's say if I want to slice this particular vector into four parts, then what I'm going to do is, I mean, so what I'm going to do is nibble of 0 is equal to data of, or I can simply write nibble is equal to data of 3 down to 0. Next, after some time, I can write down nibble is equal to data of 4 down to, I mean, 7 down to 4, and next nibble is equal to 8 down to 8, 9, 10, 11, 11 down to 8. So like this I can slice it out, and this is 7, 6, 5, 4. So I can slice this particular vector data of 11 down to 8. So like this I can slice it using my constant values. Now instead of using constant values as your indexes, you can basically use a variable inside your index. So what do I mean by this? Range 31 down to 0 data and range 3 down to 0 nibble. And let me declare one index over here int I. So what I can do this with this index, so I can simply write down a for loop for I is equal to 0, I less than 9 I'm going to take, and I is equal to I plus 1. Nibble is equal to data of, let's start I with 1. So I is equal to 1, I less than 9. So data of, I'm going to write down over here I into 4 down to, uh, here I can write down, let's say j, and let's declare one more variable as j into j, and let's increment this j is equal to j plus 1. So what is happening over here, if we check it, whenever your I is equal to 0, your nibble value will be equal to data of I value is 1, right? 4 in 4 down to 0. Now I value will be incrementing and here j value will also be incrementing. So if j is equal to 1, nibble is equal to data of, we are going to have I is equal to 1, right? I mean, here I is equal to 1 and here I is equal to 2 because we are starting with I is equal to 1, right? So 2 into 4 is 8. And specially speaking, I into 4 minus 1, if we take, it is 3 down to 0, which is 4. And next 2 into 4 is 8. 8 minus 1, 7. 7 down to j is equal to j plus 1. So it is 7 down to, what are we going to get? 7 down to 1. So let's say we are going to have reach 31 down to 0 data and reach 3 down to 0 nibble. And here, instead of using constant indexes, I'm going to use variables. So I'm going to have int I and j. So I'm going to write down a for loop. I is equal to 1, I less than 9, I equal to I plus 1. I'm going to have nibble is equal to data of I into 4 down to j, and I into 4 minus 1 down to j, and j will be incrementing by j is equal to j plus 4. So this is a logic. So if your I is equal to 1, then nibble value will be equal to data of I is equal to 1, right? So 4 minus 1, 3 down to j value is initially 0, right? So this is plus j plus 4, that is nothing but data of 3 down to 0. Now j value will be incrementing to 4. So I is equal to 2, nibble is equal to data of 2 into 4 is 8, minus 1, 7, down to 4. Next, when your I is equal to 2, next when your I is equal to 3, J value is now incremented to 8. Here J value is now 8, right? So what you're going to have, if your I is equal to 3, data of 12 down to 8. And now J value is equal to 12. Sorry, 11 down to 8. Now your J value is equal to 12. So I is equal to 4, data of 12 down to, 16 down to 12, 15 down to 12. So like this, using a for loop, we can iterate this particular variable and we can slice it and we can get the values of nibble updated. Now, this particular logic, if I'm going to use a variable inside a vector index, this is the logic I'm going to use. And this will yield a huge 32 cross, it will basically yield a larger multiplexer and it will yield a larger hardware. It is going to have more area because this for loop is incrementing it. This for loop basically this for loop occupies a larger area. Now, instead of using this particular variable as a vector index, I have an alternate method which I can use is basically simply I can use indexed part select. Now, this particular indexed part select, the syntax of this indexed part select is this. So, what is this indexed part select? I can simply write down nibble is equal to data of same logic I into 4 plus colon 4. Here, this is nothing but my base value and this is nothing but my width. So what do I mean by this? Let's explore this. So here, what I'm going to write down is nibble is equal to, this will be written inside your for loop again. Nibble is equal to data of, so here I'm going to write data of I into 4 plus colon 4. So when your I value is equal to 0, let me change the color. So when your I value is equal to 0, that means nibble value will be equal to data of, so 0 into 4 is 0. So base value is 0, colon, what is width? 4. So 0 to 3. So the compiler will evaluate this particular expression as data of 3 down to 0. Now, again, when I is equal to 1, then nibble value will be equal to data of, what is that we are going to have? So I value is equal to 1, right? So 1 into 4 is nothing but 4. So base value is 4, colon, width is 4, so 4 down to 7. So this is how the compiler is going to evaluate when we are going to write down it in a file. Now what is that it is going to do is, since the width is constant over here, compiler or the synthesizer is going to take 4 multiplexers like this. Since the width is constant over here, right? So the compiler or the synthesizer is going to yield 4 multiplexers when we are going to use this particular syntax. Now, what is going to happen again? Here, if we carefully observe, nibble of 0 is equal to data of 0 when your I is equal to 0, and nibble of 0 is equal to data of 4 when your I is equal to 1, and nibble of 0 is equal to data of 8 when your I is equal to 2. So that here I have took a 4 cross 1 multiplexer and this is nibble of 0 depending upon the value of I, which is a, what is the width of this I. So basically if I want, I can take the width of this I to be 2-bit. Okay, so it is of 2-bit. So depending upon the value of I, I'm going to decide what is my nibble values. So if my I is equal to 0, I'm going to connect data of 0. or data of 4 and data of 8 and data of 16. Sorry, I need to go up to 32-bit, right? So not 2-bit, it will be 3-bit. So here not 4 cross 1 multiplexer, I'm going to have 8 cross 1 multiplexer and I value will be 3-bit. So I'm going to have another data of 24 and so on. I mean 20 and so on. So like this, I'm going to get nibble of 0. Parallelly, I'm going to have 1 8 cross 1 mux and I'm going to get nibble of 1 over here. So nibble of 1 is going to be, if your I value is equal to 0, nibble of 1 is equal to data of 1. So here I'm going to have data of 1. And similarly, if your I is equal to 1, your nibble of 1 will be so on. So the same calculation I'm going to perform. So from here, the conclusion, if you carefully observe, and here if I is equal to 0, it is data of 1, not 4. It is data of 1. And here, if I is equal to 1, then your nibble of 1 will be equal to data of, if your I is equal to 1, then nibble of 1 will be equal to data of 5. So you're going to have data of 5 connected over here. So like this, similarly, you're going to have this multiplexes. 4 8 cross 1 multiplexes connected in parallel. So from this, we can conclude that when you're going to use this kind of syntax, which is a part selected index, what is going to happen over here is indexed part selects. You're going to have parallel multiplexes, and this will basically increase your speed of operation. So this is the difference between using a variable as your index as well as using a index, I mean part selected index. So basically the answer is also given over here. When using a variable index, a synthesizer cannot use a simple wire select. It must infer to a multiplexer tree. For an n-bit vector with a k-bit index, the result is 2 power k is to 1. This has area and timing implications, deeper multiplexer trees. So if we are using this kind of variable indexing, you're going to have so much higher delay and increased critical path. So some synthesizer tool optimize barrel shifter patterns. So if the index can exceed the valid bounds, the synthesizer may add comparison logic or behavior is undefined. But if you are going to use indexed path select plus colon or minus colon, it is preferred because the width is